Hello class, welcome to this lesson. The topic of this lesson is finding probabilities from the normal distribution. In this lesson, you're going to learn how to use technology to calculate probabilities given a normal distribution. You're also going to learn how to interpret those probabilities. In this lesson, you're also going to learn how to calculate and interpret data values corresponding to a specific percentile. So if I give you a percentile, can you find me the data value that marks that percentile? Previously, we discussed how to compute probabilities by finding the area under a normal distribution. We did some examples where we approximated the area using the empirical rule. Remember, when we use the empirical rule, we get a rough estimate of those probabilities. In this lesson, we're going to level up. We're going to use technology to calculate the area under the normal distribution. When we calculate the area under a normal distribution, we are calculating probabilities. Now, let me remind you that the most commonly used probability distribution in all statistics is the normal distribution. The reason why is because a lot of real-life scenarios follow a normal distribution. I will be giving you some real-life scenarios in this lesson. You're going to be seeing some real-life scenarios on your homework. When I first start talking about normal distributions, I don't talk about real-life scenarios because first I want you to get familiar with the probability curve. I want you to get familiar with technology, and then we can go ahead and start looking at real-life scenarios. Okay, so that is going to be the case with exercise number 1. We're going to imagine that a random variable follows a normal distribution with a mean equal to 5 and a standard deviation equal to 2. With that information, we can go ahead and create a normal distribution, and we can go ahead and compute probabilities. Now, I'm going to show you how to calculate these probabilities using technology. First, I'm going to show you how to compute probabilities using a TI-84 calculator. Let's go ahead and consider the probability of x being less than 2. What is this probability equal? I recommend that you draw a normal distribution and you highlight the area you're trying to find. If we're trying to find the probability of x being less than 2, we need to go ahead and highlight all the area below 2. And that is the image that you have here. On your calculator, you're going to use a function called normal CDF. Your calculator is going to ask you for the lower bound, the upper bound, the mean, and the standard deviation. Let's go ahead and write it here on our note. We have the mean being equal to 5, so let's go ahead and replace the mean with 5. The standard deviation here is 2. Let's go ahead and replace that 2. Now, what's going to be your upper bound and your lower bound? Recall that we said we wanted to find the area below 2. 2 here is going to be your upper bound. Now, what's going to be your lower bound? Your lower bound is going to be a really large negative value. To enter that on your calculator, you can go ahead and enter 1E99. This here is the same as negative 1 times 10 to the power of 99. So that is how we're telling our calculator that we want to go from a really large negative value all the way to 2. So that is our upper bound and lower bound. Let me go ahead and write that here. Negative 1E99 is our lower bound. Our upper bound is 2. So notice we're saying, go ahead and use the normal CDF. Take the area going from negative 1 times 10 to the power of 99 all the way to 2. Here's the mean is 5, and here's the standard deviation. The standard deviation is 2. Let's go ahead and try this on the calculator. The normal CDF is a distribution. So here, we're going to click second bars. Notice that on top of bars, we see distribution. And here we have a list of all the distributions. We're going to go down to option number 2, where it says normal CDF. Go ahead and click enter. Let me clear what I had so I can show you how you're going to enter negative 1E99. Here, I'm going to click on the negative sign. Make sure to click on the negative sign. Do not click on the subtraction sign, or else the calculator is going to give you an error. So negative sign 1. To type in E, we're going to click on second, and then we're going to click on the comma. Then we're going to enter 99. So again, to type in E, I clicked on second, comma. Now let's go down. The upper bound is 2. Let's go ahead and go down to mu. Mu in this case is 5. And then let's go down to the standard deviation. The standard deviation is 2. Go down to paste and enter. This is what we had on our notes. Let's go ahead and click enter again. This is the area below x equal to 2. Let's go ahead and round to 4 decimal places. The probability here is equal to 0.0668. 8. We should be using the approximation sign because we're rounding. We estimate that probability to be 0.0668. We can also write this as a percentage, which is 6.68%. In this first example, I'm showing you how to find the area below a given x value. Now, what if we want to find the area above a x value? Notice in part B, we're being asked to find the probability of x being greater than 10. Looking at our curve, we see that the area above x equal to 10 is highlighted. On the calculator, we're going to be using the normal CDF function. Again, it's going to ask you for the lower bound, upper bound, the mean, and the standard deviation. In this case, again, the mean is 5 here, so let me replace the mean with 5. The standard deviation is 2. Let me replace the standard deviation with 2. Now what's going to be the upper and lower bound? Well, here we want the area above 10. Our lower bound is going to be 10. Our upper bound is going to be a really large positive value. Here, we're going to go from 10 to 1e99. 1e99 is the same as 1 times 10 to the power of 99, which is a really large value. In this case, again, our lower bound is 10. Our upper bound is 1e90. Let me show you how to type this on your calculator. We're going to go to, let's click second bars. Let's go down to the normal CDF function. Click enter. Here, we're going to need to clear this. Our lower bound this time is 10. Now let's go down to the upper bound. We're going to type in 1. We need to type in E, so I'm going to click second, comma, and then we enter 99. The mean is 5. The standard deviation is 2. So let's go down. We don't need to change those. Go down to paste and click enter. You're going to see the whole expression in one line. Go ahead and click enter again. And this is the probability. This is the area above. Let's go ahead and round to 4 decimal places. We're going to say that the probability of x being greater than 10 is approximately 0.0062, which is equivalent to 0.62%. Notice on this exercise, I'm showing you how to find the area above a given x value. Now, what if you want to find the probability of x being between two values? That is the area under the curve, okay, between two values. Okay? In part C, you're being asked to find the probability of x being between 2 and 10. That means find the area between 2 and x equal to 10. And perhaps we can do this a little bit faster. Our lower bound in this case is 2. Our upper bound is 10. The mean is 5. And the standard deviation is 2. Again, I'm going to take the time to show you how to enter this on your calculator. On your calculator, you're going to click second bars. You're going to go down to the second option where it says normal CDF. Click enter. Now your lower bound in this case is 2. Your upper bound is 10. We don't need to change the mean and the standard deviation since they're the same. Go all the way down to paste and click enter. You're going to see the whole expression in one line. Go ahead and click enter again. This is the area between 2 and 10, which represents the probability of x being between 2 and 10. Let's go ahead and write our answer here. The probability of x being between 2 and 10 is approximately 0.9270, which is equivalent to 92.70%. I'm going to do the same problem, but this time I'm going to show you how to calculate the probabilities using Google Sheets and Excel. If you're not planning to use Google Sheets, you can stop this video and you can move on to the next video. Let's consider the normal distribution with a mean of mu equal to 5 and a standard deviation of 2. Here, in part A, we're being asked to find the probability of x being less than 2. The curve here on the left gives you a visual of that probability. The probability of x being less than 2 is the area under the curve below x equal to 2. If you're using Google Sheets or Excel, you're going to click on an empty cell and you're going to type in equal norm.dist. This stands for the normal distribution. Then you're going to open a parenthesis. Then you're going to enter the x value, comma, the mean, comma, the standard deviation. And then you're going to do another comma and you're going to type in true. Now let me make a remark. The function above is always going to give you the area to the left of x. In this case, we do want the area to the left of x equal to 2. So if we're going to use Google Sheets or Excel, we're going to type in equal norm dot dist. We're going to open a parenthesis. We're going to enter the value 2, comma 5, which is the mean, comma the standard deviation, which is 2, comma true. Let me go ahead and show you how to do this on Google Sheets. I'm actually just going to copy this text, and on Google Sheets, I'm just going to click on empty cell, and I'm going to copy that text. Notice I have equal norm dot dist, comma 2, comma 5, comma 2, comma true. If you go ahead and click enter, or even before I click enter, I can already see the answer. The area below x equal to 2 is approximately 0.0668. So here we have an approximation of the probability of x being less than 2. This is approximately 0.0668. We can also write this as a percentage. The percentage here is 6.68%. Now, what if we want to find the area above a given x value? For example, what if we want to find the probability of x being greater than 10? We can use a normal distribution to visualize this probability. We are finding the area above 10. Now, on Excel, we're going to use the same function. Here, we're going to use the x value equal to 10. The mean is 5, and the standard deviation is. We're using the same function. Now, what's going to happen when we type this into Google Sheets? Let me make the same remark that I made above. The function above is going to give us the area to the left of 10. Again, this function is always going to give us the area to the left. Let's go ahead and find that area. We're going to copy this into Google Sheets. Again, on an empty cell, we're going to type in the function. Notice I have equal norm dot dist, open a parenthesis, type in your x value, the mean, the standard deviation, and then type in, click enter. This value here represents the area to the left of x equal to 10. We're going to take this value and we're going to round to 4 decimal places. That is going to be 0.9938. The area to the left is about 0.9938. Now, how are we going to find the area above x equal to 10? The area above x equal to 10 is 1 minus 0.9938. Why? Because the area under the whole curve is 1. If I want to find the area above 10, then I need to take 1 minus the area below 10. 1 minus 0.9938 is equal to 0.0062. Thus, the probability of x being greater than 10 is about 0.0062, which is equivalent to 0.62%. Notice, if I take 0.9938 plus 0.0062, I get 1. Notice what we did. We took 1 minus what we got from using this function. This is not the best notation, but here I'm trying to emphasize that you're using the same function. But if you want the area above your x value, then you're just going to do 1 minus what you get from using the function on Excel or Google. Here, we wanted the area to the left of x equal to 2, and the function gave us that area. Here in part B, we wanted the area above x equal to 10. We used the same function. After using the function, we said, let's take 1 minus whatever we got from using the function. We're going to consider one more example. In this example, we're finding the area between two x values. Here, we're finding the probability of x being between 2 and 10. Now, this one is going to be a little bit more tricky, but let me explain what we're going to do. We're going to use the function on Excel. We know that the function is going to give us the area to the left of the x value we enter into the function. We're going to first say, let's find the area below 10. When we find the area, we're going to have, again, all the area below 10. That's not the area that we want. We want the area between 2 and 10. What are we going to do? We're going to go ahead and find the area below 2. That's going to give us everything below 2, which is this left tail. Once we have those two values, we're going to subtract the area below 10 minus the area below 2. If we subtract those values, we're going to have the area between 2 and 10. So again, we're going to do norm.dist, we're going to say, let's find the area below 10. So we're going to type our x value, our mean, our standard deviation, and then true at the end. Once we find the area, let's go ahead and subtract whatever we get when we find the area to the left of 2. So again, we're going to use the same function, but this time we're going to type in the x value 2. Again, what are we saying here? We're saying take the area to the left of x equal to 10, then subtract the area to the left of x equal to 2. Okay, we're going to need 2 different lines for this. Let's go ahead and do it on Google Sheet. Let me go ahead and type in the probability of x being below 10 or less than 10. That way I know that I'm about to calculate the area below 10. Go ahead and type in the function and click enter. That is the area below 10. Now we're going to find the area below 2. Go ahead and type in the function to find the area below 2. Again, this is happening on an empty cell. Here I have the function. I'm going to click enter. Now the last thing we're going to do, we're going to subtract. Once I subtract those values, I'm going to get the area between 2 and 10. Here on the left, I'm just keeping track of what I'm doing. Here I can go ahead and type in equal, and I can say take the area below 10. I'm going to go ahead and click on the cell. Then I'm going to enter a subtraction sign, and then I'm going to click on the second cell, which is the area to the left of x equal to 2. You can also do this on a calculator, right? You can subtract these 2 values on a calculator. I'm just showing you how to do it on Google Sheet. Let's go ahead and click enter. This value here represents the probability of x being between 2 and 10. That is the area under the curve between x equal to 2 and x equal to 10. We're going to take this value and we're going to round to 2 decimal places. Our final answer is 0.9938. That's equivalent to 99.38%. Now you know how to find probabilities of x being below a given x value, the probability of x being above a given x value, and the probability of x being between 2 given x values. These are going to be the only 3 scenarios that we consider when calculating probabilities.